Hello, and welcome to this intro to the Skeletal project creation tool. I'm Carl Markham. A little about me. I freelance as Code Builders LLC, where I provide services for my open source e-commerce application and build data migration applications between marketplaces like Amazon, Walmart, and eBay. I also create open office extensions, custom installations, and client applications. I'm a member of the Apache Software Foundation, and I've been involved in the Apache Open Office project for 11 years, where primarily I work on developer and testing tools and also on the security team. I'm an open source software advocate, and this project is a perfect example of how someone can take an abandoned project and pick it up, dust it off, and update it so it's usable for many years to come because it has a permissive license like the Apache v2. Okay, the agenda for the talk today, we'll talk about what Skeletal is and the benefits of using it, the project history and where we are now, how templates work. We'll show the project site and user guides. Then we'll configure a local repository. We'll create a template project and publish a template. And then we'll use that published template to create a new project, and then we'll wrap it up. So what is Skeletal? Simply, it's a tool to create software project skeletons from templates. There are three components to Skeletal: a command line application for working with templates, a Gradle plugin for adding publishing tasks to a template project, and the core templates like the template project template for starting your own template project and some other basic example templates. So who is Skeletal for? Well, I think the target audience is projects that don't have their own generator, or developers or companies that have their own common project types. There's no need to build and maintain a web or command line application, and you only need to maintain the templates. So before I get too far, I want to stop and talk about the technologies used in Skeletal. It's built with the Apache Groovy language primarily. It runs on the JVM and compiles a Java bytecode. It can be used as a dynamic or static language, or also as a runnable script. Java is also used primarily in a command line interface and some exception classes. Gradle is a software build tool that uses Groovy or Kotlin, and we use Groovy for the build script language in Skeletal. And Spock is a testing framework that also uses Groovy. Also mentioned in the talk is Apache Maven. That's another Java build tool. It's the most used build tool in the Java ecosystem, and it has an XML build file. SDKman is a software development kit manager for Unix. You can install and manage multiple versions of software like Java, Groovy, and Gradle, and many more. And then Bentray was an artifact repository service by JFrog. So there are many types of project generators out there. There are build tool specific generators like Gradle Init or Maven Archetype plugins. And most developers have used an IDE project generator. There are also some really good framework project generators. Two that I use a lot are Grails and Micronaut, which are both from object computing that have very good web-based and command line applications. So why would you need something else? Skeletal can be used for any project structure, any build tool, and any software language. If you find yourself making the same customizations to projects, like adding a database and a data model, adding logging and configuring rolling log files, or command line processing a lot of the same commands and arguments, you might find some benefit in trying Skeletal. In short, it allows highly customized templates and complex processing logic. By default, Skeletal uses the Groovy Simple Template engine to process templates into files. These templates use Groovy G-string variables or JSP-style scriptlets. You can also use other template types like Mustache, Apache Velocity, or any other template with an engine that implements the Groovy template engine. Now we'll look at the project site on github.com/cbmarcum/skeletal. There are quick links to the documentation at the top of the page, followed by developer information for building, testing, and contributing to the project, and the developer credits are at the bottom. We'll open the CLI Groovy Spock Gradle Templates main app class, where we can see the $ curly brace variables that will be replaced when the template is processed. There is a project package, name, capitalized name, version, and class name. Also note the $ variable we are using because this is also a Groovy class that has variables as part of the code that would throw an error if not replaced. Templates use a Groovy script for project creation tasks. It has built-in methods for user prompts to collect input, transforming text types between hyphenated, camel case, and property types, and processing template files into project files. It's also used for things like guessing defaults for user prompts, file renaming, directory creation, and file alterations. Now we'll look at the Lazybones script for this template. It begins with a property map to hold the variable values. Then it tries to guess the project name based on the directory using a built-in transform text method. The same with the property name and from the project name. Then it uses the built-in ask method to prompt the user for the project group, version, and package. The ask method takes 3 arguments: the prompt, the default value if the user hits enter without providing one, and a variable that can be provided on the command line instead of being prompted for. If all variables are provided, then no prompts will occur. Notice the $ variable we use to put the regular code Groovy variables back together again. The next section is the process templates method that is used for each file that needs variables replaced. The second argument is the properties map to use for the values. The next section defines directories for the sources, then moves the source files to the new directories that include the package directory names. Finally, renaming the main classes based on the user input. One of the features of Skeletal that stands out is subtemplates. Subtemplates are generated after a project is already created. It is used for adding unit tests, controllers, service classes, or any other file type you might need. They're packaged inside project templates and into the projects created in a subdirectory for later use. One subtemplate can be added to multiple project templates. I didn't create Skeletal from scratch. It's a fork of the popular Lazybones project, of which I was a user for many years. Lazybones used the bin tray service as a template repository. In 2021, the bin tray service was shut down. This left Lazybones and its users without repositories. Lazybones was then removed from SDKman after that. After I lost the use of Lazybones, I decided to fork the project. I was told by the maintainers of SDKman that I would need to rebrand the project since it was a fork. That's how Skeletal came to be. My goal was to get a working, up-to-date project creation tool. Lazybones was last updated in 2016, and there were 6 years of languages and libraries to catch up for. I implemented a simple URL-based repository instead of using the bin tray service. Skeletal developer docs are now in the project README, and application user and template developer docs are moved into the ASCII doc user guides. The command line application has commands to discover templates and information about them, create projects, manage configuration settings like adding and removing repositories, config file and cache directory locations, and mapping template URLs to aliases, and get general and command-specific help. There are 2 ways to get the command line application installed. By going to the project releases and getting the zip file, or using the curl command as shown in the user guide. Once you have unpacked the archive, you need to add the bin subdirectory to your system path environment variable. The application user guide has information about each command as if you had displayed the help for it. The commands are in the form of skeletal, command, and argument. The list command displays the available templates from each configured repository. The Lazybones project is for developers to create a new templates project. I used the config command to add a file-based repository to the configuration. When you use the config command for the first time, it will create a managed config JSON file in the user profile. This file is managed by Skeletal, but can also be edited manually. You can see the new file repository listed after the default repository. Now I'll create a template project called My Templates, and you'll notice the README as output, and that we have a My Templates directory created beside our repository directory. If we change to the My Templates directory and list the contents, we have a Gradle build project and a templates directory, to which I have added the CLI Groovy template from the GitHub project to use for the next demo. The next component of Skeletal is the Gradle plugin. The plugin allows you to manage multiple templates, giving you the tools to package, install, and publish them individually or all together. In addition, you can also easily set up sub-templates. The plugin now has its own GitHub project, and you can find a link on the main project page and then a link to the documentation from there. The docs show how to apply the plugin in your build file. I've opened the My Templates project in an IDE, and if we look at the build file, we can see the plugin applied at the top. Next is a commented out block, which is an example of how to apply template-specific properties if needed, followed by a Lazybones block with an Apache Ant style excludes for files not to package with the template, and an owner property for the template manifest. If we look at the user docs, we can find the Gradle tasks added by the plugin. There are 3 for individual templates and 3 for all templates together. We will publish all templates. In our case, we have only 1. I'll run the Gradle Publish All Templates task and then look in the Build Packages directory and see a zip file, which is our template, and a manifest file, which is a CSV file with name, version, owner, and description of our templates. This is used by Skeletal for the template metadata. Now we'll copy the template and manifest into the Lazybones templates directory, which is our additional repository. Now we'll change back into our temp skeletal directory. The list command will show our new template in the new repository. The info command will display the metadata from the manifest. Now I'll create an application from the CLI Groovy template called My CLI App. Since I didn't provide the template version, Skeletal will use the latest available, and then prompt for the other missing properties like group, artifact ID, which is used in the artifact file name and the command name. So I'll remove the hyphens I used in the directory name. Version, which is also used in the artifact name. Package and class name, which is used for the main class. And then the README contents or output that contain information about the project, its file layout, and command usage. Now we'll enter the project directory. Now I've opened the main class in an IDE so we can see the variable replacement that took place. First, the class has been renamed and is now under the package directory structure. The variables project package, project name, capitalized name, version, and class name have all been replaced. And down below, the dollar variable has been replaced with a $sign. Again, we have to do this because any G-string variable that is not found in the script binding properties will throw an error. Now I'll open the build file and point out that in addition to the Pico CLI for command line processing and Spock for testing, it has a third-party Spock reports library that I like to use, and logback logging, and it's pre-configured for rolling log files daily and also by the amount stored. Now let's run the check task to run the unit tests that come with the template. First, we'll open the default Gradle test report. And then the Spock reports report, which has more detailed information about the test code. Now I'll run the install distribution task that will build and unpack distribution in the build install directory that can be used for manual testing without packaging it first. The bin directory contains a Unix shell and Windows batch file, and the lib directory contains the libraries and the application jar file. Now back to the terminal, and I'll change to the application directory. First, I'll try the My CLI app without any arguments, and we get a missing parameters message, followed by the command usage. We can then try with the help argument and see only the usage displayed. This is a sample math application that can add or subtract integers. So we see add and subtract arguments and also version. We'll check the app version. Now we'll try some math and see the results output. Now, along with the application bin and lib, we will find a logs directory with a log file that was created by logback. The third component of Skeletal is the project templates. You've already seen the Lazybones project and the example command line templates and how you can easily create web and file-based repositories for your own templates. The last two things I'll show you is how you can create a project without user interaction beyond the initial command, and the template cache that stores templates for offline use. When you create a project with Skeletal, it creates a hidden Lazybones directory that contains a properties file that holds the values used in template processing. These are not the property names used in the script and templates, but are the third argument in the ask method that corresponds to those variables. These are the properties you can provide with the create command to skip the user prompts. You can find more information about this command in the user guide. And now this is what it looks like on the command line. If you use a -p followed by the property equals value. And now we'll look at the template cache in the Skeletal user profile where we saw the config file earlier. There is also a templates directory with all the templates we have created projects from. Skeletal copies them into the cache without the template suffix after the name. Skeletal can use these in offline mode if needed. You can even install templates directly into the cache with the Gradle plugin if you don't want to configure additional repositories. Here are the links to Skeletal and some other important links, including my company and contact information. In summary, Skeletal is a simple-to-use project creation tool for any project type. It can complement other tools or be your primary tool. You can easily add file or web-based repositories, and templates are easily created by adding placeholder variables and one additional script. Thanks for watching, and we hope you'll try out Skeletal, and if you use it, that you'll contribute to the project with your feedback, issues, and code contributions. Thanks again for watching.